So the form for a Limacon would be R equals A, and it can either be plus or a minus. I gave you an example of a plus, obviously. Plus or a minus. Let me fix that. And then some number times the cosine of theta, or they're in the form of R equals, again, some number, either plus or minus some other number times the sine of theta. Notice there's nothing inside the trig function. It's just a variable theta. So these guys are symmetric on the x-axis. And these guys are symmetric on the y-axis. And hopefully that makes sense because we're talking about cosine versus sine. So pretty self-explanatory there. All right, so there are 3 or 4 different types of Limacons, but I want to first graph this guy on the calculator, show you how that would have looked. So let me get this set up for that. So that way I can show you the calculator. Again, this is why I'm using a Zoom broadcast to record this time, because I would have the ability to see my calculator with the camera feature. Alrighty, let's move it on down. All right, so first of all, if you haven't done this, which you should have a bunch of times at this point now, if you haven't done this though, you want to move your calculator into the polar mode. So you do that under mode, and you want to switch it into the polar mode. I have my calculator in degrees right now because I was just typing in those values from the example, and the example was in degrees as well. So I'm going to just leave it like that, and we'll talk about how that can look differently. So I'm going to write it, the curve, which was 4 plus, notice I didn't say function. I almost said function. It's not a function. It does not pass the vertical line test, but it is a curve, it's a graph, so we can still graph it. I do continue to like to have that open circle with a tail because I want to see it graph it more than once if it does graph more than once. And then I'm going to go to my window next. Again, I'm in degree mode, so I'm going from 0 to 360 degrees because that's all the points that you had to have plotted in order to get that. We could do a theta step of 15, which was what we did in our example, but again, I was kind of connecting them with curved fashions because I knew that's what was supposed to happen. Your calculator would go straight to those points if you did it this way. So I'm going to go for every 5 degrees or every 1 degree. If you did every 1 degree, it would have to plot 360 points. If you do every 5 degrees, it's plotting way less points for you. So just things to think about if you're struggling with why your calculator is maybe going slow or not going slow. So this will be 72 points as opposed to 360 points if you did every 1 degree. If you only did every 15 degrees, that would only have been your 24 points, which wouldn't be as good of a picture. All right, this is your regular old, standard window, which we could start there and we could adjust that later if we want. So I'm going to go ahead and graph it, and you'll see it come around and draw my circle. Some of you guys might have it maybe look like where it doesn't connect right here. That just depends on the pixels of your calculator. The color display is nice because it's a little bit more specific. But if you have a little gap there, it's just the pixels didn't quite connect because I remember I was off by 15 degrees here, so it stopped 15 degrees away from actually going all the way to 360, according to what I had done because I'm having it go from 0 to 360. All right. If you want it to be a little more symmetric looking, you would have to go into a square window. So it would basically take those dimensions that you just had and move it into a square. And it just makes it look more curvy and more like it's supposed to actually look. This is actually what it should look like. It shouldn't be so oblong and stretched out. Okay. So if we had, let's just change this into 4 minus 4 cosine of theta, you'll see how that would look differently. Okay, same exact, and remember for purposes of pre-calc, all you really have to be able to do is to identify that this picture would have gone with this equation, or that this equation would go along with this picture. So the difference between it being a plus versus a minus in there is now we are oriented on the negative part of the x-axis, the majority of it. Okay. If I had changed this to, if I had changed this to a sign, maybe change this back to 4 plus 4 and then do a sign instead, then you'll see that it moves along the y-axis now instead. So it's still symmetric on an axis, it's just now it's symmetric on the y-axis. Notice the majority of it is up on the positive y-axis. If I change this to a minus, hope you can guess, the majority will be oriented on the negative y-axis. All pretty self-explanatory. Okay, so there's different types. So I'm going to go back to a cosine one. Change this back to a plus. So back to the original picture. If you want to investigate what happens when you change the numbers, so like what if I had made this be a, let's make this be a 4 plus a 6 cosine of theta. If you had done that, still a limacon, but it has what we call an inner loop inside of that limacon. And if you wanted, you could have actually traced that value out here. This is at a value of 10 for x. This is at a value of 2, and it does still go through the origin. Notice that this is at a value of, you can see it from your tick marks, that's at a value of 4, and this is at a value of -4. So all that stuff is coming from here. So the 4 and the -4 on the y-axis is coming from that first value of a. This value out here is coming from the 4 and the 6 added together. This value in here for the loop, that 2 value, is coming from the difference between the 4 and the 6 added together. So you'd have to recognize that if that first number is smaller than that second number, it's going to loop in on itself. If those two numbers are the same, it will just go to the origin and be that cardioid. If we made the first number a 6 and the second number a 4, it kind of gets pushed out the opposite direction. Sometimes they'll actually start to look really circular depending on how much of a difference there is there. So again, if I hit trace, you can see that this value out here is still the value of 10, which is the values, the 6 and the 4 added together. This is now on the y-axis, it's now up at a value of 6. And this is now at a value of -6. That was that first number. So that first number gives you those values up and down here. And remember when we looped in, it went to a value of 2. That was the difference between 4 and 6. Well, now because the bigger number, or the first number is larger, it's getting pushed the opposite direction, but it's still only going out to a value of -2, which is still the difference between those two values. So that's how you can be able to recognize the graph to the equation and the equation to the graph. So that's what we're going to write in here and to our notes. Alrighty. So let me get myself situated back here. If you have questions on your calculator, just reach out at another time. I know you're not live with me right now, so you can't ask, but if you have any concerns with your calculator not graphing, it might just be because your mode of your calculator and the window of your calculator maybe don't match. Okay, so let's just do the examples for cosine here so you can see the 3 different types, which means I'm going to draw you scenarios where we are symmetric on the x-axis. Okay. So for all of these, we will be symmetric on the x-axis because I'm drawing scenarios for cosine. So your 3 scenarios are, well, the one that we did, the starting out one, was if A and B are the same value, that was, of course, your cardioid. That was the one that I plotted out for you to see. So you would go out to a, and let's go with the scenario where we are addition, and then you saw from what I showed you with the calculator that subtraction would just put you on the negative x-axis mostly. So if we're going with the scenario where it's A plus B cosine theta and A and B are the same, you go out to a value here of whatever the sum is of A and B. You go to the origin, and you go up to whatever A is, and those are your 4 main points you need to make your cardioid which isn't going to be choppy. It's going to come around, hit that origin, come around, come back to here. It is supposed to be symmetric on the top and the bottom, so if it doesn't look that way, it's just because they're harder to draw. Okay. All right, then the loop scenario was when the first number A is smaller than the second number B. That is what we call a limacon with an inner loop. Remember, all of these are still considered limacones. So again, you're going to go out to a value, and again, I'm going with the scenario where it would be A plus B cosine of theta. So go out to a value of whatever the sum is of the two numbers, just like for the cardioid. So in the example that we did up here, my two numbers were 4 and 4, so that's why I was out here at a value of 8. So the first number will be your value that you go up. I guess this should be negative A right here technically, so I'm going to put that properly, negative A. Okay. And then you will cross at the origin, and then you'll loop in to whatever the value is of the difference between A and B. So you'd have to do, I guess, technically B minus A to make it a positive number if we're going to be looping. So B minus A if we want it to be that positive number that would have gone here, because remember, B is bigger than A in this scenario. So then you'll come up. You will go to the origin just like you did before, but then you'll have to loop around like this. And then you're supposed to be symmetric again, so whatever happens above the x-axis is supposed to be the same below the x-axis. I was trying to make it prettier, but I managed to make it uglier in the scenario, I think. Okay. All right, and then the third scenario is when A is bigger than B. We call that like a convex or like a dimpled, it just depends. So the picture on my calculator was more dimpled, but sometimes they will look more convex, meaning that they almost look like they could be a circle, but they are not quite a circle. So again, I'm going with the scenario of A plus a B cosine of theta. So I'm mostly oriented on the positive x-axis, so you're still out here at a value of whatever the sum is between A and B. The minus would just tell you to go the opposite, like to be on the other side. You're still going up on the y-axis to a value of A, and on the negative y, or the negative y-axis to a value of negative A. You're not going to go to the origin or touch the origin on this one, because it's getting pushed away from the origin. So you're actually going the opposite direction. I guess I still could mark this as B minus A, because in this scenario, B is smaller than A. So B minus A would put me at the negative value out here. And depending on the problem, it might be a little dimpled, or it might just kind of flatten out. It's just depending on the difference between those two values. So you'll see different, I'm going to give you different scenarios of each type where you can practice that and you can see. Okay, so I'm going to give you I'm going to pause here so the video isn't too long. I'm going to pause here. I'm going to give you like 5 or 6 different ones just to graph into your calculator of all different types so you can see the different scenarios, and then I will give you some practice. Actually, the practice is already up, so then you should be able to go and do the practice and see. And again, keeping in mind that if you were in the classroom, you would have to be able to, without a calculator, be able to recognize when you have a limacon, what kind of limacon it is, where it's going to be oriented, how it's going to look. But you guys are at home doing your quizzes and your tests and everything, so use your calculator to its advantage, and you're going to also get some funkier ones as well. If you go into the test review, you'll see some funkier ones as well. Alrighty, I'm going to stop it here. Bye, guys. Message me if you have any questions. All right.